Hi everyone and welcome to today's webinar, Simplify Migration with Risk Networks Complete App Analysis. When you joined today's webinar, you selected join either by phone call or the computer audio. If for any reason you would like to change your selection, you can do so by accessing your audio pane in the control panel. Also, from this control panel, you will have the opportunity to submit questions to today's presenters by typing your questions into the questions pane. We will collect these and address them during the Q&A session at the end of today's presentation. If for any reason we could not get to your question, we plan on responding to each of you personally through email. And the deck will be available through SlideShare along with a recording of the webinar 2 to 3 days after the conclusion of this presentation, so keep an eye out for that as well. My name is Carmen Puccio, and I'm a Partner Solutions Architect here at Amazon Web Services, and I'll be your speaker and moderator for today's webinar. There we go. All right, so before we get to risk networks, let's just talk about Amazon and what sets AWS apart. First and foremost, customers have selected AWS for years because we've proven ourselves committed to customer success, or as we call it, customer obsession. At AWS, we start with the customers first and we work backwards from there. And when you look at our roadmap, it's amazing that 90 to 95% of it is driven by what our customers tell us. When it comes to migrating to AWS, our customers are doing some amazing things. Customers look to AWS because of things like our experience, our service breadth and depth, pace of innovation, global footprint, pricing philosophy, and our partner ecosystem. I wanted to quickly highlight a couple of examples here around those pillars. So I'll start with cost effectiveness. And when it comes to cost effectiveness, GE Oil and Gas, a major business unit of General Electric, is leading the way in the company's migration to the cloud by moving 500 applications to AWS by the end of 2016. And the project entailed re-examining and, in many cases, eliminating legacy processes and thinking to achieve a 52% decrease in IT costs, greater speed to market, and the agility to compete even better in an industry experiencing immense market challenges. GE Oil and Gas is using AWS services such as Amazon Aurora, Amazon CloudWatch, AWS Elastic Beanstalk, and AWS Trusted Advisor. The division is also using AWS Import-Export Snowball to transfer more than 750 terabytes of data from their pipeline inspection machinery. In the high performance category, Expedia was building a platform called Expedia Suggest Service, which is a type-ahead suggestion service that helps customers enter travel, search, and location information correctly. They initially launched in Asia, targeting a Southeast Asia customer base, but because they didn't have a data center on that side of the world, and they really wanted their application to be close to their customers. Using AWS, they were able to get the application close to their customers, but also off the ground incredibly fast. They quickly replicated the service to our Northern California and Ireland regions, and as a result, they decreased average network latency from 700 milliseconds to less than 50 milliseconds due to the now global footprint of their platform. So when it comes to customers who are ready to adopt and start their migrations to AWS, they could run into some challenges. One of the ones we hear sometimes is upfront costs. And it's important to remember that in cloud computing, it's built around a pay-as-you-go pricing model. You pay for only what you use, and there are options in the compute category like reserved instances or spot instances that can provide you with a significant discount if your workloads fall into that model. When it comes to application interdependencies, it's a common issue that customers don't have up-to-date CMDBs and aren't fully aware of application interdependencies for their on-premises environment. This is where a tool like Risk Networks could help you in this area. These tools like Risk, they help map out those dependencies, but also help you build a right-sized TCO for your IT portfolio by exposing key metrics about your on-premise environment. We also hear about fear of downtime during migration, and this is really where you need to build out a test plan around your migration to build confidence, but you also need to look advantage of taking tools to assist in the migration to shorten downtime windows. Again, a tool like Risk is going to show you the dependency that your application server is potentially talking to a database server, so you can prioritize what moves when in the correct time frame. When it comes to lack of cloud expertise, this is where creating a cloud center of excellence is the most critical foundational investment an organization can make. And building a cross-functional team from a diverse group of individuals who are willing to learn are perfect for your cloud center of excellence. And those individuals will be the one that create a culture of experimentation and teach others as they progress through their journey in cloud adoption. So enterprises migrating AWS require expertise, tools, and alignment of business and IT strategy. And many organizations can accelerate their migration and their time to results through partnership. And it's important to remember that regardless of where you are in your cloud journey, APN partners can help you. And this is one of the reasons we have the AWS Partner Competency Program. And the Partner Competency Program has categories for the SIs and ISVs that can help enterprise customers migrate applications and legacy infrastructure to AWS. We have a migration competency inside of the Partner Competency, and that's intended to highlight partners who can help customers migrate their existing workloads to AWS while helping customers take advantage of AWS's security and architectural best practice. It also acts as a clear recommendation of tool sets like Risk Networks that drive both consulting partners and customers to migration success, and it's intended to highlight the partners who offer a low-risk path to AWS from their current environments. So what you're seeing here, this is what we like to call our migration process mental model. And it's built from the AWS Cloud Adoption Framework, or AWS CAF. And what I like to call out here is that the migration to the cloud looks like this, but as we all know, each migration has its own set of requirements and challenges because migrations are unique. And the Cloud Adoption Framework is a simple and agile process to achieving sustainable business value with AWS Cloud Services. So while we could spend a whole session talking about process and methodology, I wanted to give you a breakdown of the different categories and where tools could help you. And in this particular case, in the discovery, analysis, and planning phase, this is where you do your portfolio discovery and planning to deeply collect and analyze data about the applications in your portfolio and build a project plan. This is where you don't want to use a CMDB to discover your data center. CMDBs are usually decentralized and not in the same format as you talk to application owners, and you really want a tool to help discover that portfolio, but also map out those deep interdependencies, expose key metrics, and allow you to start to build a business case or a TCO for your migration. And lastly, before we hand it over to Risk Networks, just wanted to talk about the core migration service. So we're constantly evolving our services while trying to make it easier for our customers to migrate workloads to the cloud. And regardless of whether a customer is trying to move their servers or a database or data to the cloud, the services and tools that help with the migration share common goals, and that's to facilitate a migration to AWS by minimizing downtime and application workload impact and to try and minimize data loss. And with that said, I'm going to hand it over to Jeremy from Risk Networks.
All right, thank you, Carmen. I want to say, before I even start talking, I want to just thank Carmen and Don and the AWS team and the Turner team for taking some time out. Turner is one of our key clients, and it's a busy time of year. I hope everyone appreciates Don taking some time today. It is a busy time of year right now for Turner Broadcasting with the NCAA tournament going on and whatnot. So, Don, I really want to say thank you up front for taking some time out of your day.
Oh, yeah, no problem.
So let me make sure I've got, there we go. Okay, so my name is Jeremy Littlejohn. As Carmen mentioned, I'm the CEO here at Risk Networks, and I'm going to talk to you a little bit today about an approach to cloud migration, discovery for migration, and how Risk Networks approaches it, both from a framework and also a technology standpoint. And then I'll do a quick demo of our product for you. Then I'll let Don talk about it as someone who's used our product as part of their overall process, right? The first thing I'll tell you is that most clients we deal with are all wrestling with some value here in this chain, right? They're trying to extract value out of cloud computing. They have disaster recovery projects and initiatives. Obviously, security is a concern for everyone. Things like performance monitoring and trending, and even an ITSM model. As Carmen mentioned, CMDBs are not great for doing migration, candidly. But a lot of companies are using them for things like ITIL models, chargebacks, and stuff like that. So a lot of our clients are wrestling with these. They're trying to capture this value, but what we saw was it's just not super efficient. It takes a long time. And most of that is around the types of questions that they can ask and how long it takes to get an answer. So if they can't ask a good question about their IT infrastructure, then it's very difficult to take advantage of these other values. What Risk Networks wants to do is help with that process, right, to automate some of that and to do it at scale. So ultimately what we like to do is take assets at a customer. So discover what they have. As much as customers may not want to deal with assets, they want to deal with applications. Ultimately, those applications are made up of assets. So we need to understand what VMs they have, what operating systems, what load balancers, and so forth the customer has. Then what we do through our patent pending processes is we take those assets and turn them into applications. And that way a customer can deal with the applications and how those applications relate to these other values that they're trying to capture. So ultimately, that's what Cloudscape is going to do. How do we do that? Is a four-step process. The first is we have to collect data. Most people have silos of data, but it's not always the right kind of data, so we need to collect the data about the environment and make sure that that data is clean and relevant and fresh. Then we need to add some intelligence to that data, which we'll talk about in just a second. Once that intelligence is added, some of that we'll do in an automated fashion with algorithms and machine learning. Some of that's going to happen from the customer standpoint, or it might happen from their solution partner, their APN partner standpoint that's helping them with that migration. But some intelligence will be added to that data, and then people can start consuming that intelligence. And Don could talk a little bit about that from the, I think probably from the Turner side, what they use that for. Some of it might be cloud migration, some of it might be security or cost savings, just about shutting down machines that aren't necessary. And ultimately, people are going to act on that. So at Risk Networks, all of those things get built into features from a product standpoint. Our data collection is one of our differentiators. So we are truly an agentless collection process, meaning some platforms will say they do agentless discovery, and yes, they do from an asset standpoint, but then when you want to get performance or connectivity data, you still got to install an agent. So we're agentless top to bottom, and you can collect all of your performance data, connectivity data. We support things like flow and so forth.
All right, so I'm going to leave, by the way. My dad getting up.
The single virtual appliance that's going to be deployed at the customer premise. It's an aggregation. So again, not everything needs to communicate to the internet. Only one box would communicate to the internet. So from a security standpoint, it's much easier to manage and wrangle than agent-based solutions. And we're going to touch the Windows, Linux, Unix, AIX, VMware environments. That's what we're going to target. The intelligence we're going to add are things like automated application grouping, and we'll talk about this. I'll show this in the demo quickly. Application rationalization. So how do I understand what portions of my application portfolio will be easy to move to cloud, right, that have a low level of effort? Which ones have a higher level of effort? What will they cost when I move them there, and what will that cost be made up of, right? How much is storage? How much is network? Because I may want to adjust the way I'm moving the app. We want to make that easy to consume, obviously in our interface, which is what we'll demo today, and then easy to act on. So here, we have an SI focus. So Risk Networks is not a consulting partner. We're not going to come in and actually do a migration for you. We provide software that helps organize your environment for that type of activity. But ultimately, a partner is going to work with a customer to do the migration. Where it makes sense, however, we build integrations with tooling that does that. So that includes River Meadow, Cloud Endure, Cloud VLOX, other platforms that can help you actually do, for example, lift and shift migrations into AWS. We call what we do discovery plus analytics, so it's a little bit different, right? And we actually think of it in terms of encyclopedias. The encyclopedia versus Google analogy, where lots of people have encyclopedias, and customers have that about their data today. That's really what a CMDB is. and I can look up New York and Chicago in an encyclopedia and learn something about them. But if I go to Google and I type New York and Chicago, it's going to know, hey, am I looking for flights? What's the drive time? What's the weather difference? It's going to apply some context. So that's what we want to do for you on the IT level, is not just be a reference point that I could go look something up, but actually understand what you're trying to accomplish and help you to anticipate some of that. So let me take you through a migration story from our perspective as we work with clients. We usually get customers into our product in one of two stages. Stage number one is customers who are looking to explore cloud. They need to understand what their cloud strategy is, and they're trying to build momentum and initiative internally to take cloud on. They know it's going to be part of their future. They're trying to decide how much of a part of the future and how that looks. Then we have another cohort of partners and customers who will come to us who say, I've got to close down a data center, right? So I'm going to move what I can to cloud right now. This is a project that's, my hair's on fire. I've got to go. And then what I can't move right now or in this time frame, I need to move to another data center. So in either case, right, and you may not be in either of those, but somewhere on that spectrum, we think foundationally we need to help you go from chaos to order. So organize your environment around your applications is number one. And then once I have that organized, now I want to do some analytics on those applications in order to see about cloud as a value. So the first thing I want to do is classify those. Again, look at level of effort for running this in the cloud. Then I want to price them. I need to understand whether that's viable. And a lot of times that's valuable in its current architecture, or maybe I'm changing the architecture out to make it viable. I want to know that I have the information I need to set up all the details. So, hey, I've got to set up security groups inside of AWS to allow traffic. How do I know what goes into my security groups? Or these apps can't go to AWS today. I have to park them somewhere else, and I need to spec out that private cloud or hybrid cloud solution for that transition. Then I want to migrate them. Again, here we're going to work with our SIs and our technology partners. And then I want to track that app once it's there. So I want to see, is it doing better than it was on-premise? How does it still relate to my on-premise applications and so forth? So I'm going to take you through some of that as we go through the demo today, just so that you can see those steps within our platform. A lot of people ask us, the details of how we do this stuff, right? And we've been doing it for a long time. We've been in business 10 years. And we've got over 10,000 assessments that we've done for these that our platform's been used at. So we spent a lot of time thinking about how we can scale within a customer and also do that securely. At a high level, again, you collect data on-premise with a virtual appliance, and that data is then periodically sent to our cloud, which runs in AWS, for analysis and consumption. We do have an on-premise option here, so I want to make sure we call that out. Again, a bit of a differentiator for us and from some other platforms, that if a customer simply cannot have their data leave the environment for whatever reason, it may be their own security concerns, or it may be a regulatory issue, maybe a country of residence issue. So we can address those clients, and they can run our entire platform on-premise if they need. This is our data dictionary, just a little bit about what we collect. So we're going to, again, look at Windows servers, Linux, Unix, AIX, VMware, network equipment. We like to call that out so that, sometimes people are thinking, well, can we get into mainframes and kind of stuff like that? We can handle some of that, but we're going to look at your primary business applications is our target. All right, so I want to just talk real quickly about this issue. What Risk Networks brings to the table, besides the analytics, is scale. So some of what we do, you could do, and traditionally people have done manually. It takes a long time. It's pretty error-prone. But at some point, you graduate out of that from a scale perspective where that really becomes an exponential growth in effort. What I visualized here was 3 servers talking. And so there's just 3 servers talking here and the other servers that they communicate to. As you can see, it's chaos, right? And so trying to make order out of this at scale, in Turner's case, 10,000 servers kind of stuff, it's not feasible, right? And so people get paralyzed by dealing with that. So what we want to do is turn that picture into this picture in an automated fashion. We want you to understand how your environment is constructed, how your applications integrate with each other, the dependencies that they have, so that you can have confidence as you select AWS as a target for migration, and know that when you get there, you're going to understand the requirements to make sure that that application is functioning properly. So what I'll do now is I'm going to take you through a quick demo of our platform. We'll be real quick, 5 minutes here, but want to just kind of show you how that lays out. So what we're looking at here, we're kind of skipping the part of deploying an appliance on premise, but wanted to do that so that we could show you what you consume, right, as a customer of the platform. And what I'm looking at here, the first thing you'll notice is our platform lays out just as we describe it in our material there, which is collecting data, adding intelligence to it, and then consuming that intelligence. We also break it down to a foundation, which is getting organized, right, taking chaos and organizing it, and then getting use case specific around things like migration. So on the screen here, I'm looking at my assets, all the different types of devices that I have in my environment, and then how those assets are organized into locations. These are physical locations that you can, we automatically detect and group your devices into. It's really important because what we want to understand is where things sit and then how those locations interact with different applications, which we'll show you in just a second. So once we've taken those applications or those assets and applied our analytics to them, we're going to put them into applications. So we're automatically going to group your applications for you. Those application groupings can be modified at any time, right? So you don't have to take anything we do as the final product. You have the ability to adjust them. You can visualize individual application stacks, as I'm doing here. All right, so I can look at what makes up an individual stack and how those servers communicate. Or, as I showed you on the page before, you can see how those applications also interact with one another. So it's a very powerful platform as far as seeing all of that detail. At any point, I can get to the details of any types of communication. So if I want to understand what these two servers are talking back and forth, I can see that this is the MySQL server, right, talking to another application. So it's very simple for me to see that either within a stack or in the case of my big picture of my environment, I can see that from a stack-to-stack perspective. This, I think, is really neat. It's a feature we just added. Being able to highlight these application stacks and seeing where they connect, so you know immediately what your dependencies are, but also being able to understand what your most connected stacks are. So here I can filter my application stacks by the number of other stacks that they communicate to, and slowly come down to find out that, oh, my network monitoring is my most connected app, which makes sense, right? And I can come back out and see what all the different applications are. So very powerful tool as far as understanding, again, that foundational piece. Once we've discovered the apps, again, and organized them, now we're going to do some analytics against them. So we're going to show you things like your issue summary, so where you have problems within these application stacks. Where do I have application stacks, for example, that are running out of disk space or have performance problems, or end-of-life servers. So this may be something I want to prioritize from a migration standpoint because I'm going to have a capital expense around this server or this application anyway. And so I want to avoid that by potentially taking it to cloud. Once we've looked at those issues, we're also going to do that classification. So this is a really important piece around migration. There's several ways to use this data to approach your internal migrations. The first thing we want to do is show you the level of effort to move a particular application. These are based on AWS criteria today. So a rehostable application means that, hey, the operating system is supported. I can pick it up and I can move it. It's not using NFS. It doesn't have anything that's going to disqualify it from a migration. Replatform means that I need to do some work on it. I may have an operating system that's not supported today. It might be Solaris or something like that. And so we're going to call those out. We're also showing the top internal and external applications. So we encourage people to use this to filter which application stacks they may want to attack first. Right? Let's not do an application stack that has, what are we looking at here, 1.2 million internet customers on it. That's not our #1 target. Let's find something else that's going to be, less of a hairy beast to deal with, and we can prioritize that, especially if it's rehostable. That's an easy one to start on a migration path. We'll also show you the cost. So once you've found those applications that you feel like match a particular criteria, which you can do as a side note by using our analytics or creating your own. So we have advanced rule sets that you can utilize to create your own criteria for migration. Now you can look at cost, right? So again, this is really important. We're going to show you what we call an inventory cost, which is a like-for-like migration, versus an optimized cost. So what if I choose to size it differently? What if I get different instances? How much money can I save? And it's typically significant. You can save, at least 60% in a lot of cases. That does not even include what you might save by doing RIs, right? Reserved instances with AWS or spot instances. So if you're pricing your cloud or thinking about cloud today in terms of like for like to your on-prem environment, you are overpaying, or the TCO analysis you're using is significantly higher than it should be or needs to be. Because there's a lot of optimization you can do within those stacks to make the cost less. Lastly, I'll show you here the private cloud piece, because again, sometimes you may not be able to move everything into public cloud right away. You may have something where you have a hybrid solution. And so we give you what we call private cloud resource requirements. So this will allow you to track all of your IOPS, disk I/O, CPU memory, so that you can properly size whatever target environment you're going to. We stack this. We don't have to get into it from the demo standpoint, but we're stacking here by hours a day, different metrics and instances within those compute. The reason we show it is so that you know that it's here, right? So you'll get this level of granular detail within our platform, and you can do your sizing and planning based on that. So once you've gotten that done, again, if you think about that journey where I want to classify the apps, I want to look at the cost, I want to look at what's required to set that up, be that security rules between apps, which you can see by clicking the links, or I/O requirements for some hybrid cloud that I need to support for a time. Now I want to migrate that app. Okay? Here, again, we have integrations built with some of the leading migration tools, including River Meadow, including Cloud Endure and Cloud Velox and so forth. So you can click here and easily go to those applications and get a format that would allow you to migrate. And then ultimately, once you've migrated in, you want to continue to track those applications. So this is our performance trending module. It allows you to keep track of those applications over time, see how they're doing. You can trend our score, so all those checks we're doing for problems within those applications over time. Once it's in the cloud, you can see how it's doing versus how it was when it was on-premise. Again, you can continue to see how it's related to your on-prem environment, as well as being able to drill into individual devices and issues within those environments. Okay? So getting down to things like looking at the CPU utilization, average and max, and that kind of stuff. So the nice thing about our platform is it can take you through that entire life cycle, right, as you execute your migration, and bring you home essentially to the same data you had when you were on premise, so that you have a nice before and after comparison, and can build an ongoing management model around optimizing those environments. So again, I want to thank everybody for taking time to join the webinar today. And at this point, I'll turn it over to Don and let Don tell you a little bit about his experience.
Is everybody there? Hello, how are you? Okay, so yeah, I want to talk a little bit about like how Turner used Risk in order to help us really get our arms around our existing on-prem infrastructure in order to start our transition to the cloud. There we go. Okay, so a couple of notes, I guess, about Turner Broadcasting. We are a global media company that's a division of Time Warner. We basically, you might know us from CNN. We own and operate a lot of TV networks that are known throughout the globe. CNN probably being the most famous globally, but also here in the States, you know, TBS and TNT, truTV, Cartoon Network, that's all us, and then also we own Bleacher Report, which is a sports property we acquired a few years ago. We were founded in 1970 and started in a very meager existence with one network and have grown to basically the size we are, working as part of a division of Time Warner. So the challenge, we started this, I guess, trip to the cloud in late 2015, and our CTO realized back in, probably in early 2015, he realized that a key part of Turner's evolution and us being able to keep up with the industry was to kind of move our focus to being in the cloud and transform our business from being on-prem and running and racking our own servers to basically being a cloud-first organization. So while that sounds easier than it probably is, the challenge that we had in front of us was, how do you take 20+ years of infrastructure and pick it up and move it into the cloud? And I think a key part of that is that, Turner figured out that we, when Ted started Turner Broadcasting, back in the 70s, the last thing that he said, the last thing he wanted to do was become a data center company. Data centers are here because it's a necessity. We built a lot of custom software at Turner in order to remain competitive, and we had to run that software on something, and so we started building a data center. And then we built a second data center, and we built a third data center. So, next thing we knew, 20 years later, we're basically a data center company. And so anyway, what we did kind of figure out is that we don't need to be in that business in order to be a successful media company. So a little bit about why we chose AWS. When looking at the landscape of cloud providers out there, we wanted to make sure that we chose wisely enough. If you're turning over basically the operational aspects of your organization, you want to pick a company that you can trust and that will be there for you. And so for us, the AWS, that was a big reason why we chose AWS. Also, just the breadth of services. We felt that AWS offered more in terms of not just a kind of an infrastructure lift and shift perspective, but also as we move to the cloud and as we transform organizations, or applications to make them run more efficiently, AWS offers lots of tools to be able to do that. So that was the kind of, I guess, the root of our AWS choice. So why we chose Risk Networks is an interesting story. So what happened was, like I said, late 2015, I started an organization here at Turner whose job was basically, I had one charter, which was take us to the cloud. And when you think about starting that in an organization of this size, it can be a little daunting. And so the first questions I started to ask was, well, how many servers do we have? How much money do we spend on our data center? Like how many VMs do we have running in that data center? What does our networking infrastructure look like? How much storage do we have? How utilized are the things that we have in the data center? And it became quickly apparent after I started asking those questions that we really had no idea. And in talking to people, you know, as we've gone through this and talking to other companies, I'm learning that this is a pretty common problem. Turner wasn't, you know, the only company who's looked at its, you know, the sum total of its couple decades of data center build out and thought, I have no idea what I have. And so we got together and decided that we needed a tool to help us get our arms around what was there. And so we went to AWS and said, hey, you know, we need your help. We want to pick this stuff up and we want to land it in AWS. But in order to do that, I need to have a better understanding for what I had or what I have. And AWS suggested that we look at Risk Networks, that they had a tool that could help us figure this out. And so we kind of did a POC and with Risk and realized that this is the exact data that we needed. We needed to know this exact stuff. And as you saw in the demo earlier, you know, what you saw there, we saw on our side when we scanned our own infrastructure only, you know, times 100 kind of thing. I mean, whereas there might have been, if there's 1,000 servers in that demo, we discovered, you know, 10,000. So, you know, it was really like a critical part of our early success was being able to understand what we had, and that is what Risk provided us. So to talk about the process that we went through, we went ahead and after doing a small pilot, decided that Risk was the right tool for us, and embarked on a you know, getting it kind of spun up within the organization. And what that means is, you know, we had some point people on the infrastructure side who could make sure that we had the right ports open and, you know, the right server configurations, and had a couple of people on my team who got trained on using the tool and understanding what the data that it was generating for us meant. And then we kind of turned the scans on, and we waited about 30 days because we really wanted to get a full understanding, not just of what we had, but also how utilized that stuff was. And in order to really get a sense of the utilization of the servers, it needed to run for, you know, more than just a couple of days. So, so pretty quickly we had an understanding for, like, okay, we've discovered like 12,000 VMs out there, but let's keep things running because we really want to know of those 12,000 how many are being used. So Risk basically, you know, we allowed it to do its thing. We started collecting the data. We started kind of looking at it, and we basically created these two buckets, which was a cloud-ready bucket and a non-cloud-ready bucket. And those buckets were, I think, the genesis of our original cloud migration plans, because what Risk showed us was these servers with these apps on them don't have NFS dependencies. They don't have dependencies on, you know, on-prem LDAP servers, and they don't have, you know, some other, you know, kind of on-prem dependencies. So it quickly identified, you know, 2,000 or 3,000 machines that were, you know, ready to go to the cloud just as is. The other bucket, which was a much larger bucket, which was the not cloud-ready bucket, was what we then kind of used in a lot of our modeling and forecasting. So, you know, now that we know we have, you know, several thousand machines that need to be touched in order for them to be migrated, and then the apps, like, and what apps are running on them and what they're talking to, we could start to kind of formulate a migration plan. You know, like, what would it take to get these non-cloud ready things transitioned over to running in AWS? So I guess the takeaway I want to make sure to emphasize here is that in order for us to successfully get off the ground with an effort as large as we had, we had to be able to show our leadership at the company that we could do this, and we could do it in a way that we wouldn't overspend. And in order to make those guarantees, we really needed to understand what was in front of us. And so using all the data that came out of the Risk scans allowed us to put together cost models, to put together migration models, basically do a lot of Excel work to show people with confidence, this is what we have in front of us, this is how long it'll take us to move, and this is what we think it will cost us once we wind up in AWS. So I think I probably hit upon some of the things on this slide in my monologue a second ago, but you know, just to call out some of the benefits of Risk Network, you know, we were able to construct an effective migration plan because we had all of the servers, we had a list of the machines, we knew what those machines were talking to, we could create move groups, and all of a sudden we could identify applications and all of the interconnected pieces of those applications, and really kind of plot a trajectory that would take multiple years. One of a really interesting side benefit was once the scan was done, there was a little over 1,000 servers that were immediately identified for targeted for turning off. It's funny, you just don't know how much dead infrastructure you have until you do something like this. And when you know, I always tell people that our data centers were kind of like a dark room, and you could open up the door and you could peer into them, and you could see lights blinking, but you really had no real understanding for kind of what was inside of there. And Risk allowed us to illuminate that room. And once the lights came on inside of that room, all of a sudden we could see that, well, we kind of forgot we had those 500 machines that were serving content in 2008 that have been replaced but never turned off. And so we kind of embarked on this you basically like mass, I guess the best way to put it is this mass decommission session, where we just like started decommissioning servers left and right. So we knocked out 1,000 probably in a month. And since then, we've actually knocked out another probably 600 just by then like grabbing low-hanging fruit and saying, okay, well this was being used, but it was barely being used, and so let's combine these two things together and shut that thing off. And so we were able to do that. And then the other thing really is like, you know, analyzing the kind of like subdivisions of the infrastructure and breaking the entire thing down into consumable chunks was important. You know, it's, you know, the old adage about, you know, how do you eat an elephant, you know, one bite at a time was kind of the approach that we're taking. And so if you look at your data center and think, oh my God, I don't even know where to start, and you need a starting point, something like the information that Risk provides gives you a place to start. It gives you some tangible, you know, tangible things you can actually like look at and say like, I can go get traction on that segment of my infrastructure. And then once you have that traction, you can parlay that into traction somewhere else, and then you can kind of build that snowball, which is, since we started in July of last year, I feel that the snowball is, we're doing a pretty good job at building it. So I think that's it. With that, I'm happy to take any questions from anybody about how we went about it.
Hi, everybody. So my name is Alan Brown. I'm going to take care of curating the Q&A. If there are any questions for Don and Jeremy, I will address those directly. We have quite a few questions that have come in throughout the session already. If you have any others, please let us know now. I'm going to try and summarize as many of them as possible into themes so that we can get through them as many questions as possible. If there are any that we can't address directly, each question will be answered directly if we aren't able to address within the recording. So please feel free to enter questions. If we don't get to them, you will get an answer. So Don, I have a question for you immediately that sort of comes up around some of the specifics of your implementation, if you don't mind giving us some information. So when you finally started started moving to AWS, did you use Direct Connect as part of that, and how did you use Risk to figure out the gap between applications that you could move today over that infrastructure and those where you had to do some work on the application before you could shift them across?
Cool. So on the Direct Connect question, yes, we did. In fact, I think one of the most important early moves that we made was establishing a relationship with Equinix who is a data center provider outside of US East, and racking up gear in Equinix in order to establish direct connects between Turner's facility and AWS, or at least US East. Because it provides us, reliable, quick connections between here and there, and so it makes moving things much better and easier. The other thing that it did for us is we were able, what we call like extend the 10 space bubble into AWS, and so, like anyone else, we have a private, we have a series of private networks within Turner that, all have 10 space addresses, and what we did was we extended the 10 space via their direct connects into AWS. So as we migrate something from on-prem to the cloud, if it has dependencies on another app, it can still reach that app. We have so many applications that are so interdependent amongst each other, you can never pick everything up and move it at once. So traversing direct connects from US East down to Turner was critically important. I think the second question had to do with what was that? It was like
yeah. So I mean, a bunch of questions on the same kind of topic have flooded in the last 30 seconds or so. But how did you use Risk to figure out which applications you were going to kind of lift and shift, and which ones you had to do a little bit of work to re-platform onto AWS? How did Risk help you make that assessment? And can you give us some indication of how you've actually executed on that? Did you end up doing a lot of lift and shift? Did you end up doing a lot of re-platform? What was kind of the balance between those? And how did Risk help you do that?
Yeah, cool. So so the first thing I'll say is that I think the most important illustration that we were able to ascertain from using Risk's tool to show us the infrastructure was we were able to see those interdependencies I was talking about. So we have, if CNN.com is not one app, it's 100. It all kind of surfaces itself as this one thing. And so what we're able to look at is okay, so these portions of CNN.com, this one takes like a MongoLab dependency, that one takes a Postgres dependency, this one talks to that one, which talks to that one, which talks to this other thing with an LDAP thing. Okay, wait, that one stays. So let's grab the two that have the Postgres dependency, they don't really spider web out into anything else, and let's mark those as cloud ready and move them. So, kind of establishing the entanglements that existed within the infrastructure and isolating the ones that did not have many entanglements and marking them as ready to move immediately was like a huge benefit of using Risk to look at the infrastructure. The second part is understanding what those entanglements were once you found like the other pieces that weren't cloud ready. And so we had huge NFS dependencies, lots and lots and lots of NFS. We also had lots and lots of dependencies on like these legacy Chef servers that were doing migrations that were touching, like huge swaths of our infrastructure that was built in maybe, let's say, between 2009 and 2014. And so understanding the dependencies there and then how to basically tease apart that web is we got from like the whole creation of move groups and looking at those like this app is tangled with those apps, and if I sever these connections and move these things up into AWS, then I can use the direct connect to get back to this one thing that I left down here. And so that graphical look at it is what we really relied on Risk for.
Okay.
Yeah.
And then I sort of have a follow-up question. I could ask Jeremy this, but I think it's easier to ask you. You could probably give us a customer's point of view on this. But how much manual work did you end up having to do to get the results that you needed out of Risk once it had done all the discovery work? Did you find that it just did a lot of magic? And I suppose this goes into a lot of areas: the infrastructure dependency mapping, the application grouping, the cost analysis and recommendations. Was that very, very automated, or did you still have to invest quite a bit of manual effort into that?
I mean, my barometer for a lot of effort and someone else's may be different. I didn't feel that we invested a lot of time or effort into it. We got a lot of answers straight from Risk. We did two things I think that were critically important. We not only did we use Risk's portal and Risk's tool to kind of help us understand things, but we also did a lot of exports to Excel. So we were able to take the data that Risk provided us like dump a lot of it into Excel, and then I was able to give it to people on my team who were able to kind of like start costing things out. So one of the things that Risk did that was super interesting was it gave us specs on the machines that it scanned, and it gave us utilization on those machines, and then it also gave us recommended sizing, like what were the recommended sizes in AWS for the exact, kind of like based on the usage of the thing and based on the specs of the machine, we think you should be running on a C3 large. So we dumped that information out of Risk and imported it into spreadsheets, and then took the spreadsheets and plugged in lots of costing stuff and started generating cost models. So I don't think that's a lot of work, but I mean, considering what we had in front of us, I thought it went pretty smooth. There was a question earlier about, the lift and shift versus, like how much do we lift and shift versus how much do we change things in order to make it happen in the cloud. I want to make sure to emphasize that the goal of the migration effort that we are under, which is a 4-year migration effort, our goal is to minimize the amount of lift and shift. But even with that, we still think that 40% will be lifted. We'll just straight up pick up the machine and drop it in AWS and let it run as is.
Okay.
We can't modify everything, kind of thing.
Great. So 2 follow-up questions, then I want to move on to Jeremy, a couple of questions about Risk that have come through, specifically the implementations. How many people do you have working your migration project today, and how is it going? Are you guys on plan?
So it's going well. We are on plan. So the approach that we chose to take when it comes to how many people are working on the migrations is we do not have a centralized single migration team. There's a team of cloud architects. There's an operations team for the cloud, and then there is an organization of about 600 developers and PMs and BAs who built all of the applications that run Returner. What we've done is gone to those teams and said, this is an organizational priority. We would like to be on your roadmap for 2017, 2018, and we need you to migrate your stuff to the cloud, and we will help you in that. We don't want to do this to anyone. We don't want to do it for them. We want them to do it for themselves, because Turner is a very decentralized shop, and we're not a very top-down, like there's lots of rules and everyone must, everybody must use Node, and like we have, if you pick a language and a platform, we've got something running in it, and so for us, it's more about how do we take a decentralized approach to enabling the organization to take their stuff to the cloud than it was building a team of people who will migrate everyone to the cloud.
Okay, great. Don, thank you very much. It's great to hear the story, and good luck with the rest of the migration. Jeremy, I have a couple of questions for you. We've got about 5 minutes left before we need to wrap up here. So I think the one that's come up a couple of times, and I've seen a couple of questions sort of either directly asking or alluding to this, is how do you think about the security of your customers' data? So, does the data ever leave the appliance? If it does leave the appliance, how is it secured? What do you think about customers who are sensitive about the data that you're collecting about their infrastructure?
I think that's a great question. We get a lot. So for one thing, we provide a very secure cloud environment, obviously running within AWS. We've been through our AWS well-architected review, which for those of you who don't know is a requirement in order to be certified in any of the AWS programs, right? So we're providing a very secure environment in the cloud, but we also understand that certain customers, for whatever reason, that's never going to be, they're never going to be satisfied with that. And so that's why we offer our Flex Deploy option, so that they can keep all of their data on-prem if they want. So they have both options, right? We routinely sign NDAs and share a lot of information about our security architectures with customers, such as penetration scan results and Cloud Security Alliance assessments and those types of things. So we provide that to them for our cloud environment, or they also have the choice to run it on-prem. And we find that those two options usually satisfy 99% of the customers that we interface with.
Okay. Can you comment on the risk pricing model? How do you work with customers around costing? You know, I know a component of that is the data storage component of it and how long the data remains available. Can you just comment on the pricing model and how that ties into sort of how long the data is available and how long the service is available for?
Yeah, absolutely. So we have evolved our pricing model over the last year and a half, and we think we finally got it right where customers would like it, which is what we were searching for, right? So we're very much like AWS. So you pay for what you load into our platform. That's it. However many servers you want to collect on at any given time. So if I want to license 100 servers and collect on 100 servers right now, I can commit to a year of that collection or only 30 days of that collection, whichever I want to do. Any data that's collected in our platform lives for a year. So if I collect 30 days of data, I'm still going to have access to that data once I stop collecting for another 12 months. And so it gives them lots of time to execute on their projects and have access to the data that they need. So you're just paying for how many servers you want to be collecting on at any given time. It's a very flexible model. Those licenses can be moved around. So I can select 100 servers today, 100 servers tomorrow, 100 servers the next day if I want. And I've still only spent 100 licenses. It's a concurrent collection host. So it's a very flexible model for customers. They can kind of, depending on their use case and what they're trying to accomplish, they can collect it, but they never have to worry about how long the data stays. All data stays in our platform for a year.
Okay, and a couple of questions, you know, come out around the agentless the agentless aspect of the tool. How does that reach into systems to understand infrastructure dependencies? Can you give a little bit of information on how that actually works to give the information that it does?
Yeah, absolutely. So, I mean, it depends on the system, right? So we're going to use WMI for Windows. We're going to use, which is a standard Windows Management Instrumentation interface. We're going to use SSH or SNMP for Linux. We prefer SSH today. And so it's going to go to those boxes and collect the data. For example, for SSH, it's going to SSH to the server and run commands, right? All of those commands that we run are documented on our website. So you can see precisely what we're going to do and restrict if you want that account to just doing those things. So customers have granular control over what we do. We do the same thing now. Our database modules in preview, so you can collect database information as well, such as size of tables and schemas and that kind of stuff. If you're looking to migrate, for example, to RDS, then you need to understand if that database will be compatible when you go. So all of that is agentless, right? The other thing that we take in is we will take in flow data, network flow data, or do packet capture. So we can color all of that communication that we're tracking agentlessly with flow data and give bandwidth and latency and that type of information about those connections. So that's a big difference. Again, a lot of people talk about on agentless. What they're really saying is we'll go to vCenter and we'll pull an inventory agentlessly. That is correct. But now if I want to go back and collect performance and connectivity data, how am I doing that? In most of those cases, they're going to have to, not in every case, but in a lot of cases, they're going to have to go back and put an agent on. And again, I think, you know, to Don's challenge, you know, sitting in an environment with 10,000 servers, if you have to put an agent on 10,000 servers, that by itself is a giant project. And so it can be a significant roadblock to getting something done efficiently and effectively. So
and risk clears that out. It doesn't require that agent.
Correct.
Okay, great. Jeremy, thank you very much for talking to us about risk. Don, thank you very much. Con, thank you very much. Thank you very much, everybody, for attending. We're out of time for this webinar. Again, if you've asked a question and we haven't managed to get an answer in, we will make sure that you get one. And the recording and the slides of this will be available shortly for this webinar. Thank you very much, everybody, and have a good day and have a good evening wherever you are in the world.